You're going to take a look how much steps or how many steps will it take to find the last element, which is at index number 31, using binary search. So the number that we are trying to find is 992. How does binary search works? The first step in binary search is it identifies a starting index and a ending index. In our case, the starting index is 0, the ending index is 31. In the next step, binary search calculates the midpoint using the starting index and the ending index. The midpoint is calculated by adding the start index with the end index and then dividing it by 2. Remember, the division operator in Java is going to return you the quotient. So 0 plus 31 divided by 2 is going to return 15. This is the midpoint index of this array. After calculating the midpoint, binary search is going to do comparison. It is going to compare the number that is at the midpoint, which is 418, with the number that we are searching for, 992. It is going to answer the question, is a number that we are trying to search for less than, greater than, or equal to the number that is at the midpoint? In this case, the number we are searching for is greater than the number that is at the midpoint. Binary search is going to discard the left side of this array. What does it mean, the left side? This means all the numbers, all the elements that are before the midpoint are going to be discarded. Why? Since this array is sorted, if the number we are searching for is greater than the number that is at the midpoint, this means number is going to be on the right side of the midpoint. Basically, any index that is greater than the midpoint. So there's no possibility that 992 will exist in this half of the array. So binary search in the next step is going to discard this half. How does it do it? It changes the starting index to midpoint plus 1. So in the next iteration, the starting index is 16, which is midpoint plus 1, and the end index remains the same. The same step is repeated again. Now, a new midpoint is going to be calculated for starting index plus end index divided by 2. In this case, it is going to return 23. So 23 is the new midpoint. As before, the same process is going to repeat. The element at the midpoint is going to be compared with the number that we are searching for. Is the number that is at the midpoint equal to, greater than, or less than the number we are searching for? We can see that the number that we are searching for is greater than the number that is in the midpoint, which is 627. This means the number 992 that we are searching cannot exist in any of this index that is less than the midpoint. So binary search is going to discard this array. What does this mean? This means that the starting index is going to change and it's going to be midpoint plus 1. So the starting index is going to be 24. A new midpoint is going to be calculated, 24 plus 31 divided by 2. The answer is 27. The same steps will be repeated. The comparison of the element that is at the midpoint, which is 828, with 992, because that's the element that we are trying to find. In this case, again, 992 is greater, so this means we are going to move the start index to midpoint plus 1. Now 28 plus 31, a new midpoint is calculated, and then the same comparison is done. The number we are searching for is still greater than the midpoint. This means our start index is going to be midpoint plus 1. A new midpoint is going to be calculated with 30 plus 31 divided by 2. And then the same comparison is going to be done. Still, the number we are searching for is greater than the midpoint. So this means our starting index is going to move forward and is going to be midpoint, which is 30 plus 1, so 31. Now our midpoint and our end index are same. What is going to be the new midpoint? 31 plus 31 divided by 2 is going to be 31. Now comparison is going to be done with the number at midpoint is equal, greater, or less than the number that we are searching for. In this case, we can see that the number are equal, so this is the number that we are searching for, and then so that we return the index, which is 31.